In learning objective B and C, we're going to focus on reading tables and making conclusions and reading graphs. So clearly this one right here is going to have us start off by reading some graphs. So here's what we have. It says examine each cause of unintentional injury death for the age or ages at which that cause is most prominent. And they want us to look at what did we find for these particular 4 categories. So if we look at motor vehicles, we're going to look at the graph and read it carefully. First of all, look at the title, Unintentional Injury Deaths by Age and Event in 2004 for the U.S. We want motor vehicles, which is going to be the red line, and some of the key points are marked with the X. And they want to know at what age is the most popular death for that. And if you look, it's going to be right in here. So just go on down, and I would say approximately 20 years old. Okay, for falls is next. The falls is the blue line with the kind of the circles on it. So if we look at that, the falls look like it's about right here, probably somewhere around 82 or 83 years old. Poisoning is going to be the yellow line with the triangle here. And the highest death age for poisoning looks like it's right about here, and possibly about 40 years old, 42 years old, somewhere in there. And the last one, suffocating, this is going to be blue with the rectangle. Looks like the suffocating is going to happen somewhere, maybe right here on the blue line, possibly around 85 years old or so. Okay. Then they do ask us, do we think the statistics are useful? And I think in this case, they definitely could be. If you were trying to put a public service announcements on television, maybe about motor vehicle deaths, knowing that the 20-year-olds are the most likely to succumb to death in that way, you would target that audience, so you might make a more youthful type of commercial. Now, if you went through Learning Objective A already, we already started this problem, so let's continue on with B through F. Again, they went into the city of Boston and they surveyed 2,145 inline skaters. They asked them what level are they. They were beginner, average, or advanced. And then they asked how many pieces of protective gear do you wear? No gear, 1 piece, 2 to 4. And they tallied up how many people. In total, again, we see in the table it's 2,145 people. These 3 numbers in the row will add to that. These 3 numbers in the column will also add to that. So the question in part B we actually already did, so let's actually go just to see. What percent of skaters wore no gear? So to figure this out, you have to decide who are they talking about. They're looking at all of the skaters, so it's all 2,145. What percent of them wore no gear? Well, if you look at this, when you read down, 874 wore no gear, so you're going to do 874 divided by 2145. As a percent, it's going to come in at about approximately 40.7%. Okay, letter D. What percent of beginners wore no gear? Well, if you look at it, they are just now looking at just the beginners. So they are isolating the data and just looking at all the beginners. So the total of that is going to be just out of 709 people. What percent of them wore no gear? 188. So this is 188 over 709. And as a percent, this comes in about approximately 26.5%. Okay, letter E, how many skaters said they were advanced? Okay. How many skaters said they were advanced? We're just looking at the total here. So and that's just a numerical is how many. So 754. And then the last one, how many advanced skaters wore protective gear? So we are just looking at the advanced skaters. And in this case, if we isolate them, we have this row circled in the black. And how many of them wore the protective gear? Well, these people and these people. So I'm going to add those 2 together. And they, again, want a how many. They don't want a percent, so 382. Now, as you start to analyze data in tables, there's 3 questions you do want to ask yourself. You want to ask what is being presented. And the key to doing this is before you start doing the problem, just look at the table. Here it says we have income of households by highest education level of householders in 2005. So we have the incomes. This column here, the highest level of education that someone in our table had. Here we have the number of households that actually responded. Then they have it broken down. Be careful. This data went from account, from here. This is a percent, so to be very careful. So, for example, of the 6,088 people who had less than 9th grade education, this is the percent of the 6,000 people that made under 10,000. This is a percent of the 6,000 and some that made over 100,000. And then the last column is back to an amount. It's the median income in dollars. Okay, second question. Are the data trustworthy? So as you continue to read it, you're trying to look at the source. And the source is right here. This source is from the U.S. Census Bureau. It was a population survey in 2006. Now, the source is the U.S. Census Bureau. We should assume that we can trust them. So yes, this data is worth looking at. If it wasn't worth looking at, we would just scrap it and don't do anything with it. And then the last question you ask yourself is what conclusions can be drawn? And on the next slide, we're going to look at the data a little bit more and make some conclusions. Okay. Let's start with A, same table of data. What variable is represented by the row heading, and what kind of variable is it? What is the other variable in the table? So if you think about it in rows, rows versus columns, by the way, on a building, when you build a building, you have these walls with the roof, right? These are called columns. Columns go up and down. So know that these here are considered the columns. Therefore, these guys going horizontally are the rows. So rows are horizontal. So look at the row headings. Our row headings are this right here. So we have on here 5 different rows, and what are they represented by? This here is the highest level of education. Now, they're going to ask you, is this a numerical piece of data, or is it that other word that we called categorical? When they surveyed these people and they gave their response of their education, is that a numerical answer, or is it non-numerical? Clearly, this is non-numerical. When it's non-numerical, we call that a categorical answer. So they gave us a word, would be categorical, versus these other columns that we see, or right here and here, this is all numerical responses. Okay, part B. What kinds of information are represented in the columns? Okay, there we go. Numerical information. Okay, I'm going to say it's the numerical info. And we have a variety of things. We already talked about here we have how many, the number of counts. So we have the number. Here we also have the number in dollars. So we have some counts, we have some dollars, and be careful, this right here when you read it is all percents. So the numerical information is dollars, counts, and percents. Part C, interpret the table entry of 31,153 in a sentence describing it in context. So here's that number right here. And if you had to describe that in context, what you might say is, of those surveyed, we had 31,153 people who had a bachelor's degree, I'm just going to do that, or higher. Okay, part D, write a statement relating median income to the education of householders. So our median income is over here, and we're going to look at it in relation to the education. So as the education changes, what do we see happening to the median income? Well, what I would say for letter D is as education, I'm going to use an arrow, increases, you would use the word increase, we see median income also go up or increase. Okay? And then the last question here, letter E, is asking us, how many times as likely was a family to have the income of at least $100,000 if the head of household had graduated college rather than not started high school? So we want to isolate what we're looking at. And we are looking at, again, let's break it down. How many times is likely as a family has an income of at least 100,000? So we're looking at that particular column. If the head of household had graduated college, so someone that graduated college was this one here, rather than not started high school. So they didn't even start high school, so it's that. So they want us to compare, these are two percentages, how many more times likely? So the question for that, if you're looking at the math on that one for E, would be if we did 2.2 times something equals 36.2. How would you solve for X? Well, you would divide by 2.2 on both sides if you did the math. And it's going to be that X is about 16 times more. So this is actually interesting information. If you don't have any high school at all versus if you have a college degree, you are more likely to make 16 times more in your median income. As we look at reading graphs more, there's another type of graph we should focus on a little bit, a bar graph. This is a regular bar graph. This is showing us, again, read it carefully, the median income of our households by education level. So it's just a picture of the median income by those education levels from that previous table. This one here is called a stacked bar graph. This is representing our inline skaters. Here's their skating level, and then it just tallies up if they had no gear, 1 piece of gear, 2 to 4 pieces of gear. So this column shows everyone who was a beginner, and that tallies up to 100%. So bar graphs are important because they help you to determine or support conclusions. It's a nice way to solidify your answers. What you're going to do is, they're appropriate to use when one variable is categorical. For example, what is your education level? That's categorical. What is your skating ability? That's a word, it's categorical. But look at the other ones. Here, income is considered numerical. So you'll see bar graphs being used. Again, it tends to be down here on the x-axis is the categorical data, on the y-axis is the numerical. Now, to make them, just some things to keep in mind. First thing is make sure you have a descriptive title. You want to identify the variables being described. You're going to see in the stacked bar graph, they identify the variables right there. In here, they do identify the variables down in the x-axis. 3 is you're going to label the numerical scale. And you're going to do that in equal intervals. And you're going to notice here that they do, for example, on these percentages, they count by tens on every line, but they've labeled them by 20s. And then you're going to use bars of equal width. You don't want these one bar to be skinny and one to be really fat. You want them to look about the same so it's not deceptive. And then the last thing, when it's needed, you do need to provide a legend if the data is from more than one sample. This right here, because it's a stacked bar graph with different colors, you do need to have a legend of your data.